Today, today we're going to talk about sector area and arc length. How is proportional reasoning used to find areas of circles, circle sectors, and lengths of arcs? We're going to find the area of sectors and find arc lengths, sector of a circle, segment of a circle, arc length. We may have done this one. We may have done this lesson a little earlier, a couple weeks ago, perhaps. I can't remember if we did or did not. I looked at the lesson plans and we were supposed to, and I think I may have skipped over it. So it may be a review, but if it is, it's a good one because you're going to need to make sure we know how to do this going forward. Okay? All right, first up, guys. A sector of a circle is a region bound by two radii of the circle and that intercepted arc. Okay? So when I talk about a sector, very simple. If you need a real-life example, pizza, right? A slice of pizza is what we're talking about here, okay? A slice of pizza. That's all that I'm talking about, right? Or a slice of pie or something along those lines, okay? What's confusing is not so much that we're talking about a pizza slice, but it's this right here, this formula right here, okay? The area of a sector of a circle is pi radius squared times the arc measure over 360. On your formula sheets, this shows up as theta, all right? It's just what it is, excuse me, theta, which is just the arc measurement. Okay, good deal. We're going to move forward and come back to it if you need it, all right? So let's look at this example. Find the area of each sector. Give answers in terms of what? Pi, and round to the nearest hundredths. All right? Let me tell you what. I don't care about the pi part. I want your answers in decimal form to the nearest hundredth. Okay? Coach, when I say hundredth, how many decimals does that mean? Two. Tens? Hundredths? Yep, that's right, Coach. Good job. Okay? Sector HGJ. Alyssa, what's the radius here? Perfect. Alyssa, what would be this radius? You can expect to answer the same question pretty much all day. Okay. I appreciate your participation. Your grade will reflect it. Jade Bell. Nope. Cameron. What is the arc measure of JH? Perfect. The arc measurement, watch, I'm going to write this, is theta. Theta is 131. Okay? So in my formula, pi times radius squared times theta over 360. Look at your formula sheets on your desks if you haven't crumpled them up already or you know, like twisted them so that nobody else can read them because you're really bored and cool and stuff. Look on the right side. See if you see the area of a sector. Maybe it's down at the bottom. Actually, you know what? It's at the very bottom left. Area of a sector equals pi r squared theta over 360. Y'all know what that means? It means we can put all this in our calculators at one time. Okay? Y'all hear me? We can put all of this in our calculators at one time. So this expression is the same as pi r squared theta over 360. Let me teach you how to do this. Okay? Get your calculator. On your calculator, hit the fraction symbol. Right? Type into the pi symbol. Okay? Then hit times, put parentheses, put 12 parentheses squared, like that. By the way, so far? Hit times, put 131.
Yeah, we lost.
Oh, was it the numbers?
No, it was the calculator.
Right? So put it in there exactly like you see it. Pi times parentheses 12 parentheses squared times 131, and then for your denominator, I want you to put 360. Yes, ma'am. You have a pass? Okay. What do you get?
262 over 5.
That was pointless me even doing it.
Did you get this answer? Because until you get this answer, it's not pointless. 262 point what?
262 over 5 pi.
Oh, put it as a decimal.
162 over
164.
0.61.
See, Mr. Bradley, it's not pointless. What is it? Meters squared. How about that? Right?
Oh my god.
Oh my God.
Do I know the right thing?
The answer?
No.
You could.
Why would I just write the answer?
You don't have to write. You know what? You know what? If you just want to watch and learn, you can. Of course, when we get to our classwork and, I watch you watch and learn, If not, you can get it from somebody, okay? All right. Y'all see this? All right. Hey. I got a question. Guys, if I wanted to find the area of the whole circle, I'd do what? Pi times 12 squared, correct? Right? Pi times 12 squared. Okay? Well, the area of the whole circle is going to be what? Bigger or smaller than the area of just the section? It's going to be bigger, okay? Right? You should see that a lot of these examples, okay, are going to make a lot of sense. Josh, type into your calculator, pi times 12 squared. Hit enter, change it to a decimal, and tell me what you get. 452.38. That's the area of the whole circle. This is the area of just part of it, right? Okay? That's all we're doing. What did I just do? That is the area of the whole circle in blue. Pi radius squared. Right? Pi radius squared. Jade, when I find the area of the whole circle, how many degrees am I putting in for theta? It's a tough question. Think about it. Everybody listen, everybody stop what you're doing. If you're on your phones, just stop for a second. Do what? Alright, so hey, check it out. If I want the area of the entire circle, how many thetas is that? 360. Right? If I put 360 here, that'd be 360 over 360, which is 1 whole, right? So I'm multiplying that times 1, correct? See, in 3rd grade, when they told you the area of a circle, they messed up bad, right? Here's why they messed up. And here's why I'm ticked off at all 3rd grade teachers in this country. Okay? This is the area of a circle formula. That's the area of a circle formula. Okay? That's the full area of a circle formula. Coach, you picking up what I'm throwing down, right? You guys, they lied to you. They're biased.
So how do we know you're not?
Do what?
How do we know you're not?
Would my theorem work here?
I'm just joking.
I know you are. I am too. They're not really liars. They're just geometry teachers.
They're just joking.
But it's not anything they did wrong. Alright, check it out, guys. Hey, if I do 360 over 360, that's just 1, okay? So you know what happens in 3rd grade? Instead of having to teach you what theta is and all of this other jazz, they cut the formula down to that. Right? Or 4th grade, or whenever you learn the area of a circle. Maybe it was last year. I don't know. Okay? Right? Y'all see what I'm saying? This is still, don't let this intimidate you. Alright? You don't realize it, but you've been doing this all along. It's just that you've always put 360 in here. Okay? Right? And you've never done this last step. The only thing we're doing is adding one more number to our area of a circle. All right. Understood I in the English language, which Coach is going to give you an example of by the end of this class. Right, Coach? Thanks, man. All right, here we go. Find the area of each sector. Give your answer in terms of pi. Round to the nearest hundredth. Take 2 minutes. Set up the problem. I will do it in just a second. Take 2 minutes and set it up. Who set it up like this? A equals pi times 16 squared times 36 over 360. Perfect. You did? You did? You just decided not to raise your hand? I'm trying to give you praise. I'm trying to give him praise, Coach. I'm trying to praise Katie West. Don't like it. Don't like it. No problem. Yeah, guys, all you gotta do is, it's kind of easy, right? 16 squared, 36 over 360. Voila. Yes, it is that simple. Okay? We will keep it that simple. Got me? We're going to keep it that simple. Every problem we do with one of these, we want to get it right back to that somehow. Okay? What was the answer? 80.42 inches cubed. Right? Perfect. Now, and windshield blocker plate's 18 inches long, the square inch was the air cut by blade rotates to an angle of 122. If a blade is 18 inches, what's the radius? 18. You ever been in a car? Wiper blade? Yeah. Wiper blade? 18 inches. Correct? As it rotates, the angle is how much? 122. Coach, look at this drawing.
Spot on, Charlie.
It's pretty awesome, right? How do I calculate that area? Now you know. The area would equal pi 18 squared, 122. If it went a full rotation, that'd be 360 degrees. Don't even worry about it.
That's it.
That's it, man. Don't make it, hey, let's keep it there, right? I got arc length, which is very, very similar, okay? So I got to worry a little bit about arc length, okay? So first, let me talk about segment of a circle. It says it's a region bound by an arc and its chord. What, Mr. Bob? I don't get it. You will, okay? Guys, listen to this. The area of a segment, all you got to do is this. Find the area of the sector, subtract out the area of the triangle. Let's do a quick review. Area of sector, I used the what formula? Yeah, the area of the sector formula, right? You're good, Camry. Pi, radius squared, theta over 360, and that's music to my ears when she says circle formula, because that, if you get it, that is the circle formula. But when you find an area of a circle, you just don't have to put in this part, okay? Right? Or if you want to, put in 360 for theta.
Right beside the arm.
Theta. The bottom of your formula sheet, you'll see that symbol down there, okay? Alright, ooh, hey Camry, back to you. What formula do you think I should use here? Oh. You're so close. If I use the area of a sector formula here, what should I use here? Let's see how elementary this is, guys. Area of a triangle. The area of a triangle is base times height divided by 2. Base times height divided by 2. Everybody got me? Base times height divided by 2. Okay? Examples. Oh, Mr. Hobbs. Mr. Hobbs, what have we done here? Alyssa, you just got back. What's the radius here? Perfect. Alyssa, what's the radius from L to N? Thank you. All radius are created. Yeah, so while you were gone, we talked about this formula. Understand what I got to do here. The question says, find the area of segment L, N, N, L, N, M. I want to find that particular area. Okay? I want to know what this little deal is. Okay? How do I do it? Find the area of the sector. How do I find the area of the sector? Use the area of the sector formula, right? Ooh, and then the hard part comes. Then I gotta find the area of the triangle. Okay? 1/2 base times height. 1/2 base times height. Okay? This is where it's gonna be trickiest, I think, for you guys, is to find the base on this. Alright? They use some trigonometry to find it. Alright? They use trig to find it. So this is 120 degrees, right? This is 120 degrees. Each of these particular angles would have to be 30 degrees. Okay, so you can use some trig to set this problem up. I tried to go a little bit easier on you guys in our classwork today, so it's going to be a little bit easier. The problems will be, okay? But if I use trig to try and find my height here, right? I would have to use 4.5, half of 9, right? 4.5 times, no, I'm sorry. I would use, so it's here, 9, so this would be 9, and I'm trying to find I've got the hypotenuse, I'm trying to find the opposite side. What am I going to use? Sine of 30 equals h over 9. How about that? I made it a lot easier today, okay? Don't have to worry about that. Probably confused everybody. I confused Coach, didn't I, Coach?
Yes, sir.
Okay, good. If I subtract those out, right, I'm subtracting out the area of the sector from the area of the triangle. I'll have the remaining shaded region. I told you we had to go to arc length. Mr. Bradley, quit making duck faces, and let's write this down. Arc length is the distance along an arc measured in linear units. Linear units, okay? On your formula sheet, the first formula below circumference of a circle is arc length of a circle. And by golly, wouldn't you know it? They've got it again. 2 pi radius times, and it'll say theta over 360. How about you? Coach, do you think when they came up with the formula for circumference of a circle, they used 360 for theta? Nod your head yes.
Yes, sir.
Yes, sir, they did, by golly. They didn't teach you that in community college?
No.
No, Coach.
No.
4-year guy.
Well, you're right. Yeah.
Yeah. 6 years for 4.
About 6.5.
That's what my sister did too.
It's hard
Okay.
squeezing in, 4 years into 6.5.
Yeah. Okay. Y'all will learn one day. All right. So make sure you get this concept down. Okay. Conceptually, when I'm talking about just part of a circle, I'm gonna have to multiply by a fraction. Right? Because everything's set up in circles for it to be 360 over 360, which is the same as 1. Very good. Hi. Mr. Hobbs, I need an example of what you're talking about. I will grant your request. Find each arc length, give answers in terms of pi, round to the nearest hundredth. It would help if you could see where F is. F is right there. I'm wanting to know what the length of FG is. Now, let me stop. Collaborate, listen. Ice is back.
Brand new games or something. They're holding me tightly. From
We're done. Alright, so, very good. Let's see what y'all were doing. Alright? Hey, we're talking about a length here. Length. Yeah, so when it asks you for a length, use the formula that says length. Right? It says arc length. So if it says find the arc length, Katie Bates, what formula do you think you'll use?
Hold on.
You don't have to, just tell me the name of it, the title of it.
Arc length of the.
Arc length.
I thought she was asking me what it was.
No, I'll get to that in a second.
2 pi.
Guys, if you're asked to find the area of a sector, what formula do you think you use? This is not confusing. The area of the sector formula,
Yep.
right? Is it,
That's too hard, guys.
Coach, I'm just not gonna talk about it, okay? Alright. I'm gonna be about it. Alyssa, what's my radius? 8? Katie, I'm trying to find arc length. Give me my formula, please.
Which Katie?
Bates. Katie West doesn't like praise.
Art. 2 pi r. Whatever that thing is.
Theta.
Yeah. Over Katie.
Theta club.
Alright? Hey, it would help out, guys, it would help out if we figured out what R and theta were first.
R's radius, right?
R is radius, and what's the radius, Alyssa? Yes. Theta changes every problem, right? Y'all got me? Theta changes every problem. So theta is something on the first problem, another thing on the next one, and so on and so forth, right? What other number is on the board? What do you think theta is? This was pretty simple, right? So now, it's all about if you can use a calculator properly, okay? Mr. Bradley? Mr. Bradley? Can we type that fraction into our calculator? Seriously, that's what, yeah, with 100% accuracy. I'm not lying. Y'all need, like, these are gimme problems, you know what I mean? Layups, free throws, y'all got me? These are the problems you need to get right every time on the EOC and on these tests, okay? Because if you start getting them right every time, those grades go straight up. Your formula. It all goes back to the difference between finding the circumference versus finding the area. Okay? Great question. Did y'all hear Camry's question? Did you hear Camry's question? Is it your fault? Is it his fault? They're throwing you under the bus, son. Camry's question was, I know, and I saw you right, so I think that they're lying. Camry's question was, why don't I square the radius here? Okay? It's not in my original formula. That's why.
Okay, can you give us the answer, see if I can get it right?
What's the answer?
18.7.
18 point what? 7?
7-0.
Okay? Oh, ooh. Is it centimeters squared or centimeters?
Centimeters squared. No, I'm joking, I don't know.
It's just regular old centimeters, right? Unless you see squared here in the radius, you don't have to worry about squaring it.
See, this is all we're doing today.
Sit, boss man.
Okay, so can we go
Okay.
ahead and get to work?
If I asked you to you in a word problem, could you put together what all that meant? Then we will skip over that one,
Maybe.
and we done.
Let's go.